Welcome to Iron Wolf Academy. In this course, we are comparing Claude Fable 5 against GPT 5.6 to help you make smarter deployment decisions. Over 12 sections, you will learn how to balance cost, safety, and raw capability against your team's specific workload constraints. We will look at how Claude's guardrails compare directly to GPT 5.6's Luna tier so you can avoid critical errors in production. You will also see how Anthropic's Mythos to Fable evolution contrasts with OpenAI's Luna, Terra, and Sol Spectrum, giving you a clear deployment strategy. Finally, we will dive into token economics, comparing raw pricing against prompt caching and batch processing for high-volume setups. In this first module, we are examining model architecture families to help you determine the right deployment path for your organization. Different AI developers structure their model lineups in fundamentally different ways, and understanding these approaches is essential before you build. We will compare Anthropic's strategy marked by their Mythos to Fable shift against OpenAI's tiered Luna Terra Sol Spectrum. By contrasting how these two major ecosystems categorize and evolve their model architectures, you will gain the clarity needed to evaluate which provider's framework best aligns with your specific performance requirements and technical strategy. When you look at modern AI providers, you are no longer dealing with a single monolithic model. Both major vendors break their top-tier intelligence into distinct model families, giving you a tiered toolkit instead. This structure is a huge advantage for your operations because you only pay for the exact level of intelligence your current task requires. Depending on what you are building today, you will need to balance strict safety constraints against raw processing capability. Keep in mind that features like vision and multilingual support are now standard baseline expectations across the board, so your main strategic decision comes down to matching your performance needs with cost efficiency. When you look at this architecture, try not to view guardrails as something that slows your progress down. In an enterprise environment, they are essential structural components. What makes Claude Fable 5 so significant is that it delivers the exact same level of performance you see in Mythos, but it wraps that power in much stricter safety boundaries. This specific design allows you to put frontier-level intelligence directly into your workflow while adhering to strict compliance frameworks. Ultimately, it means your production agents can operate with maximum capability and high reasoning power without putting your organization at risk of regulatory violations. When you look at the GPT 5.6 lineup, your primary decision comes down to balancing raw intelligence against operational cost. You don't always need full frontier power for every deployment. For standard enterprise workloads where volume matters, Terra gives you a balanced mix of performance and affordability. On the other hand, if you require specialized capabilities like vulnerability research, Sol is built specifically for those cybersecurity demands. And if your team just needs a reliable tool for everyday coding tasks, Sol Pro provides a practical path without over-provisioning your resources. Ultimately, you should select your tier based on whether your focus is driving sheer volume or accessing targeted domain expertise. When you're evaluating your model architecture, you do not always need to pay top dollar for everyday tasks. SolPro offers a sweet spot in the lineup, giving you robust, high-level intelligence for your routine development workflows at roughly half the expense of the flagship model. This means your engineering team gets the capability they need without inflating your budget unnecessarily. It proves that high performance doesn't have to carry a maximum price tag. Keep this tier in mind for your next architecture review, especially when you need to justify costs, because it allows you to optimize your spend while maintaining a very high standard of intelligence across your daily operations. When you evaluate different model architecture families, data retention policies become a critical factor for your privacy strategy. Vendor policies vary significantly. For instance, Claude Fable 5 strictly mandates a 30-day data retention period for every request processed. OpenAI, by contrast, gives you more flexible privacy configurations without forcing a mandatory covered model status. Because these vendor approaches differ so fundamentally, you must actively align your model choice with your team's specific compliance requirements. Never assume default settings will protect you. If your operations demand a true zero retention policy, you need to explicitly verify that guarantee with the provider before you begin integration. Let's look at how model pricing structures compare, because where your money actually goes might surprise you. The biggest factor here is the massive gap between input and output costs. OpenAI charges 4 to 6 times more for output than input, and Claude Fable sits at $50 per million output tokens. Because generating answers is so much pricier than reading your prompts, overall conversation volume ends up being the primary driver of your bill if you're on Claude. The good news is you can optimize this. Both providers support caching and batching, which slashes the cost of processing repeated data. When we look at current model architecture families, multimodal and multilingual capabilities have shifted from advanced extras to baseline expectations. For example, with GPT 5.6, vision processing is handled as a standard feature right alongside text, and robust language support is fully expected for this release. That said, not every model setup is clear yet, as current research remains silent on what specific modalities Fable actually supports. Finally, as you evaluate these architectures for your own operational needs, keep compliance in mind. If your organization relies on strict zero data retention options, you would want to directly check the vendor documentation to ensure those guarantees are in place. Now we move into Module 2, where we focus entirely on cost and efficiency mechanics. When you are operating high-volume workloads, relying solely on standard, raw token pricing structures can quickly scale your expenses up. In this section, you will evaluate two key operational strategies to optimize your spending: prompt caching strategies and batch processing workflows. We are going to weigh both of these approaches directly against raw token rates, giving you a clear picture of how they alter the economics of your system. Ultimately, this will help you choose the right execution model to maximize efficiency and control costs as your workload demands grow. When you are running repetitive workflows, prompt caching is one of your primary mechanics for driving cost efficiency. By leveraging cached prompt history, both vendors let you slash your input token cost by 90%. That gives you a massive economic advantage when handling predictable high-volume tasks. However, you have to manage the operational trade-offs carefully. While caching keeps your expenses down, holding on to stale data can actually skew the model's behavior over time. The key takeaway here is balance. You want to capture those huge token savings, but you must remain mindful of how outdated context might alter your model's outputs as time goes on. If your tasks don't require an immediate answer, you shouldn't be paying full price for real-time processing. OpenAI's Batch API allows you to submit requests that process asynchronously within a 24-hour window. The primary driver here is cost efficiency. In exchange for removing the need for a synchronous response, you receive a 50% discount off standard token prices. This strategy is tailored specifically for heavy, latency-insensitive workloads. Think nightly data pipelines or background batch inference jobs. Whenever your processes can afford to run without demanding instant results, taking advantage of batch processing instantly slashes your operational API costs in half. When you look at models with similar baseline capabilities, it's easy to assume they'll perform identically in production, but safety mechanisms change that equation. Adding stricter guardrails fundamentally alters how a system handles ambiguous or edge case prompts. A highly capable model might refuse a request quickly, or it might take a moment longer to process a compliant, safe response. In regulated industries, taking that extra beat for a safe, useful answer is far more valuable than a rapid refusal. As you build, you have to decide what matters most for your specific workload: getting unconstrained raw output or ensuring absolute adherence to safety and ethical boundaries. Before you even choose a specific model tier, remember that caching is your first line of defense. It significantly lowers your costs for repeated inputs right from the start. Once you are selecting a model, Luna is the ideal choice when you are managing high volume that outweighs the need for maximum intelligence. It keeps your expenses to a minimum on repetitive tasks without giving up essential baseline capability. Unless your application faces strict latency requirements or very unique safety constraints, you should avoid stepping up to higher tiers. Sticking with Luna gives you the high volume cost efficiency you need without overpaying for extra power you do not actually require. When you skip internal benchmarks, you leave your model selection entirely to chance. Without your own performance data, you are forced to treat vendor documentation and tier definitions as your absolute truth. That means your deployment decisions end up driven strictly by the vendor's stated cost structures rather than how a model variant actually performs. Simply put, trusting marketing claims instead of conducting direct internal testing invites catastrophic failure once you move into a live production environment. If you want to manage cost and efficiency mechanics effectively, you cannot let vendor documentation be your only guide. You must validate the performance mechanics yourself before committing to a deployment. What you see here encapsulates the core framework of Iron Wolf Academy. At its heart, our entire model boils down to making smart, intentional choices. You will gain the exact practical skills needed to evaluate your specific workload constraints and match them directly to the ideal model tier. It is all about knowing how to evaluate trade-offs, recognizing when to prioritize cost efficiency, when strict safety parameters are non-negotiable, and when you simply need maximum capability. Once you master balancing these competing factors against your unique operational requirements, you can optimize every deployment decision. To dive into this approach, visit the web address on screen.